I wanted to do one of these questions with you because I feel like the example that she chose to do in the book was not super indicative of the rest of the types of questions that you might get, because it was specific to a semicircle, whereas quite often you will not have that. So I want to show you how to handle it if you do not have that, like I gave you in your homework. And again, the thing that you have to do when we're doing a question like this is be very strategic about how you set up your coordinate plane. So if I set my origin right here at 0, 0, then I'm going to do some labeling of these points to help us along the way. So if I move to the right here, and I know that the whole top of my trapezoid is 4, and I've set 0, 0 as the center of the top section, then over here, this must be 2, 0. And this point down here is, because my height is 3, but I'm starting up at 0, then this is at 0, -3. And that would make this point, which the whole bottom section is 2, and so then half of 2 is 1, so that's just 1, -3. So those points should help us, and I don't care about the ones on the left side because I'm just going to focus on the positive right side right now. Keep in mind, again, the formula that we're using, and that is to find the fluid force of the tank by taking the weight density, and I didn't specify, but this is in water, so this is submerged in water, and the weight density of water is 62.4 as we've been practicing. So I'm going to take the weight density of water from C to D of H of Y, L of Y, dy. So some of these are going to be pretty straightforward and easy, and some maybe not so much. So obviously we already know that the weight density of water is 62.4, and my limits of integration would be from -3 to 0. And again, those could be different for you if you set up your coordinate plane differently than mine. It's totally okay to do that. I just like to make it as simple as possible. So I like to put that coordinate plane or the origin right there in the middle. Then H of Y is basically, again, if we're imagining little rectangles that we would draw, H of Y would be the distance here down to that, which is the depth. Remember, this is depth. And so with the way that I drew that, that's just -y. The L of Y is the harder one, and this is why I was a little bit disappointed in the example that she showed with a semicircle, because she didn't really show what happens if you don't have a semicircle. So L of Y, remember, is the length of this. I should not use white because I've already used white for my coordinate plane. So let's think about, again, my little rectangle here, and then L of Y is that distance. Okay, so this distance up here was H of Y, which we said was -y. So L of Y is going to require a little bit of work for us, and this is what she didn't show you. Remember that really what I'm trying to do is I'm trying to find an x value, because that distance would be an x value. And just like she showed you in the last example, there's going to be 2 of them. So we are going to take 2 times whatever we find L of Y to be, because from here to here is the same as from here to here. And that's, again, why I'm focusing on the positive side. So now what I'm going to do is figure out, how do we find L of Y? So she had a semicircle, and so she isolated a circle, the equation of a circle, and then she was able to take that x value times 2. I don't have that. I don't have a semicircle. So what I have instead is this line. Yes, I'm using blue again, sorry. So I have that line to the right in blue, and what I need to do is I need to find the equation of that line. So I'm going to use the points 2, 0 and 1, -3, and I'm going to take y minus my y value, I'm going to choose 0, equals the slope. So the slope would be 0 minus negative 3 over 2 minus 1, and then x minus 2. So hopefully you're very familiar with point slope form. Y equals, so I have a positive 3 on top and a 1 on the bottom. So this is 3 times x minus 2. Now keep in mind that I'm really interested in getting x by itself. So I have y equals 3x minus 6. So y plus 6 equals 3x. And so if I divide by 3, I have y over 3 plus 2 is equal to x. Now keep in mind, like I said, that I need 2x. So 2x is equal to 2y over 3 plus 4. So this is the value for L of y, because that x value is this length, and then times 2 gives me the part on the other side that would be identical. So back up here, I'm going to write 2y over 3 plus 4 dy. And now we can do the math. So that gives me 62.4, and I'm just going to do a little bit of simplification. Still from negative 3 to 0, I'm going to go ahead and distribute. And what I'm going to do is I'm actually going to take this negative and pop it out just to get it out of there. So I'm going to put it in front of my negative, or my 62.4. And when I distribute that, I get 2y squared over 3 plus 4y dy. Then I would have negative 62.4. I would get 2y cubed over 9 plus 2y squared, integrating from negative 3 to 0. And that gives me negative 62.4. And then, of course, I would plug that 0 in first, so I would get 0 plus 0. So I'm just going to put 0 minus, and then if I plug in the negative 3, I would get negative 3 to the third times 2 divided by 9, which gives me negative 6. And then y squared would be negative 3 squared times 2, which is 18. So that gives me negative 62.4 times, again, if I've got a negative here, I end up with negative 12. And when I multiply those together, I get 748.8 pounds. So again, the hardest part of this is determining the L of y, which is going to require you to either know a geometric formula like she did with the semicircle, or be able to find the equation of the line. And always know that if you're putting that coordinate plane right in the middle, then we're just going to be taking it times 2 because it's the same on each side.